Okay, let's get started. So first of all, a little bit about the setup here. If you've not been to one of these type of seminars before, you should have on your panel a question area, and if you have a question, you can put that in. I can even unmute your microphone if you want to talk. If it gets complicated, then we can do that. So, but I usually ask you to send a question, and I'll try to get to it when I can, and we'll sort of tidy them up at the end. So I said before, my name is Gwyneth, and I'm a mean full-stack developer. Either way they get these terms. Anyway, I am a full-stack developer, which means that I work on the front end of the project. That's the web front end, web development area. And I also do the back end. So I would tend to do. Now I work on some smaller projects as I'm an independent consultant. So I tend to be the person that does all of the parts. Some people focus on the front end, and some focus on the back end. It turns out that mean, and I assume you've all come here to find out what does mean actually mean. Well, it's a number of technologies that are sort of glued together and often used together, similar to LAMP, which you've probably heard of, only it's a different set of tools now. And one or the other of them could be replaced for something else if it was more suitable in your application. So mean stands for Mongo, MongoDB, if you've heard of that before. And it's a document-based database as opposed to maybe an SQL relational database. It falls into the category of the NoSQL. They call it NoSQL. And it has a specific purpose, and it fits in very well with certain types of applications. So that's one of the first things that we'll be talking about. That's Mongo. Okay. E is Express. And Express is a web development framework. And traditionally, it's more like the type of frameworks you might have used before. So in the back end, probably a lot of people have heard of Ruby on Rails, for example. It's kind of similar to that, only it's for Node.js. Or Django. If you've worked with Django, I do some work with Django. Or even anything that you might use to develop a web application in the traditional sense. That's the piece that does that. There are other ways to do very simple REST interfaces without using Express, but it's a pretty good tool for putting that together. One of the things it does is provide RESTful interface, which we often use, and I'll mention that a little bit later. So that's Express. Okay, A, that's Angular. And Angular is a front-end technology. We're going to be talking about Angular 4 today, which is the sort of current release, about to release a little bit more. They've gone to a different release schedule, but I'll get to that in the chapter. There was the original Angular, now dubbed AngularJS, and now it's Angular, just called Angular. But they're releasing a new version, a major version number every 6 months now. So that's Angular. And of course, the last one is Node.js. And Node.js is kind of the engine that everything runs on. So we're going to cover each of these in a little bit more detail, tell you a little more about each of them as we proceed through this session this afternoon. Okay. Once again, for those people that just joined us, if you have a question, you have a question panel on your control there, and if you just put a question, I'll see it on my screen and I'll get to it when I can. Or if it's a long involved question, then we can unmute your mic and you can have a chat here with me. That works for you. So here we go. One thing that's important is you might want to follow along with the material that I have here, and we've posted a link in the chat window, and I think everybody sees that. If you don't see that link, let me know and I can put it in the question, and then you can get it that way. And that's a PDF file which contains the materials that I'll be using here today, so you'll be able to follow along if you like. Okay? So these things weren't in any particular order. It just so happens that at the beginning of the book is Mongo. So we'll start with Mongo, and we'll work our way through and see where that gets us. Before I do, I'll just tell you a little bit more about my background. I've been doing mostly web development now, and as I said, full stack. I often work on embedded web systems. There's lots of small systems like PBXs and lighting control systems and things like that, that all of the interface is done via web interface. So I tend to work on the smaller systems like that, although the principles are pretty much the same. And so I'm not a full-time instructor. I work for WebAge Solutions, and I teach most of the front-end courses at these things that we're talking about. However, I also do a lot of development. So in the rest of the time, I'm doing web development. So let's dive into Mongo. So in this chapter, we're going to find out some basic information about MongoDB, a little bit of background on where it came from and where it's going. It's a specific type of database, and it's actually lends itself quite well to certain types of applications. So with these tools, it's not really a question of, oh, well, throw out everything you did before and we're just going to do this now. They have certain purposes that they fit into, and some of them are pretty much inevitable. You're going to pretty much use them in most cases. So you have to decide how they fit into your particular environment. Okay, so the MongoDB query language we'll talk about, and also we'll sort of contrast it with Couchbase. If you heard of Couchbase, their motto is just relax. And it's another NoSQL type document database. There are several that are available. Mongo is probably the one that seems to get the most press. So MongoDB is an open source document-oriented. You've seen me use that term, document-oriented. And essentially what that means is that we'll build a document which would be probably in the form of a JSON document, JavaScript object notation. And we'll see some examples of that shortly. And that is sort of it's a technology that's somewhat replaced the use of XML, which was very prominent in years gone by. And the main reason is that it's more efficient, but it also, it's more efficient and it's a little bit smaller. So when you're doing a web page, you can get a JSON document faster and process it faster, and the response time is quite important. So these are what they refer to as the documents. So you can take a JSON object in your application, and you can send it to the MongoDB and store it directly. Okay, so that's where it fits in very well for that type of application. Then you can go back and retrieve it. You put them in collections, but a little bit more to come on that as well. So again, it falls into the category of a NoSQL database, or not only SQL, as we sometimes say. That you can use SQL databases in this environment. If it depends on where your data is and what you're trying to do with it, and if that works out for you. But this is one of those not necessarily SQL databases. So we don't use SQL to query it. We have another mechanism for that. It is supported by MongoDB. Used to be 10gen, now MongoDB Incorporated. Dynamic schemas, that's one of the things that's different from the traditional SQL database, and that is that there really is not exactly a schema, because you can put a document with almost anything in it. So that means you don't have to create a schema and migrate schemas and things like that. So you're relieved from that, but there's no hard and fast rules that kind of keep track of things, right? Another question here. Will we be able to get a copy of your slides? Actually, you should already have a copy, and this is a good one. I'm going to, as an answer to your question, I'm going to try to paste that link. Okay. Here it is. I'm just going to try to copy that link, and I will paste that as an answer to your question, and I will send it to everyone. Okay, so you should got that, and send it to everyone. You should have that. So you can just download the PDF, and that's a copy of what I'm using here. Okay, sure. So JSON-based documents are serialized internally in Mongo into something called a binary format, binary JSON format, and they go directly onto the data store. This is a little bit of internals. It doesn't have too much effect on what we're doing. Some of the other features is auto sharding. It does handle replication somewhat better than some of the traditional solutions. So you can have data replication and sharding, so you can have multiple servers that can serve the same information, and the servers talk to each other and resynchronize. So it does support data replication fairly easily. So we're talking about not really hard and fast structured documents, but they can be shared over a wide area, and they're very quick because they don't have to be converted from their format that they appear in the web browser to the format that they get stored in. There's very little conversion goes on, so it's much faster for that sort of thing. So each shard is treated as a independent physical database partition, and the idea of shards is that we can have sort of multiple copies that can serve multiple areas. So they have a query mechanism. It's not your traditional SQL type query mechanism, but searches can be performed. You can go by field or ranges or regular expressions and things like that. But all you're really trying to do is gather a series of documents that you've stored into a collection. So a collection can hold JSON documents, and then you can do a query and pick out certain ones or all or whatever the case may be. They do have indexing support for faster querying, so you can build an index on a particular field, and you can index any field of the document for your query. So if you have something that you're always looking for people by telephone number, you could put an index on the telephone number, and you would presumably get much better performance when you're querying by that. So it does use a master-slave replication type approach, which means that the master performs reads and writes, while slaves can be used for reads. So we get something like this, where we have a master, and we do all of our writing into the master, and then there's one or more slaves here, and the master then would propagate the writes to the slaves. So that's a fairly common pattern for replication. It's a simple pattern, can't go too far wrong, but that means that for retrieving it's going to be very fast because there's three slaves, that, three possible nodes that can provide the information. And the updates, which there's probably going to be less of, you'll pass them all through the master. The master will do the update and propagate it to the slaves. So that's the type of architecture that they use for that. So the idea is that the slaves then always would have the information that they got from the master, but you don't write to them directly. There's their logo. They become MongoDB. And of course you can find them on the web pretty easily, and they've got good documentation and things that you can use. So here's where things are positioned with respect to other types of databases. And so there's this line shows more functionality going this way, and that is that a relational database would have more functionality, in particular in the area of referential integrity, keeping the data fitting a certain hard and fast pattern or schema, whereas Mongo doesn't use schemas. So that's just an example of one of the things that it might do. So, but there's more functionality, but in terms of scalability and performance, then Mongo is better at that, because you can see very easily make slaves, and you get better performance because you don't have to construct a SQL query to get your data and then convert it to JSON, which is how it was done not too long before that. Moving up the scale here, they're mentioning something called memcached, and this is essentially a cache. You can store things in it similar to Mongo, and you can retrieve them, but it doesn't have near the functionality of Mongo, and particularly in persistence. There's another one that fits in probably somewhere in here called Redis. You may have heard of Redis. Okay, so that's got more functionality than memcached. Probably not quite as fast, but not the functionality of Mongo, but it's another one that you might have heard of. Again, another NoSQL database that allows you to store documents. It's a key value store, similar to memcached, and but probably a little bit more functionality. So there's one that we can add to that list. So MongoDB is administrated by a command line shell-based, and it's based on JavaScript. So the language is similar to JavaScript that we're using to do that. So there's no administration graphical interface to use. In fact, I'm going to, in a few minutes, I'll show you where I'd set up a small database here on Mongo. It supports a number of different clients, so almost any platform that can access it, they would have written a client for it. So we're going to probably talk about using it with Node.js in this context. It can be used with Python or Ruby or almost anything else, C, C++, Java, C#, and so on. So they have what's referred to as a database connector that is in that language that will allow them to connect to the Mongo database and retrieve and insert data into the database. So Mongo holds a set of databases. You can actually have multiple databases similar to a relational, and each database has in it collections. And collections are kind of like tables in concept, kind of like a table and relational database. The difference is that a collection, they don't all have to be the same. It's just a collection of objects. So they can be any type of document that you want. You put them into that particular collection. So you can arrange it as you see fit. It is possible for you to use the traditional keeping a collection all one data type and ensuring that it matches patterns that you've set up. It's possible to do that, but it's not sort of standard out of the box. Like in the case of a relational database, you must create a table, you must define the data types in the table, and so on. Well, with Mongo, you don't have to do that. You can pretty much put whatever you want in a document. Okay, so if you follow some of these rules, then it's less likely to bite you later, but they're kind of optional. Right? So collection holds these documents, and it's the instance of similar to a row, we call a row or a record in relational database, but again, it's just a document and it may or may not have all fields, and they don't have to be predefined. You can put them in as you like. So it's a set of fields, and don't all have to be the same. They don't all have to follow the same pattern. And for some things, that's useful, right? It is, again, uniquely identified by a primary key field, as in a relational database, and that's its unique identifier. So each document then within the Mongo database would have a unique identifier, and you can either provide one yourself or Mongo will provide one for you. So there's the default generation of the primary key. Limitations. There's always limitations. There's the good and the bad, right? Okay, so distributed and multi-document transactions are not supported. So transactions in the traditional sense. So make sure we update this one, and this one before any of them get updated. That kind of thing doesn't work. So you just putting that document in there, and I'm putting that one in over there, and not necessarily related to each other. So you have to kind of do that yourself. The reason they don't do that is because it will affect the scaling, right? So they don't have distributed transactions. That can get very complicated. However, if your application is designed so that it doesn't require this, you could possibly put several pieces in one document. Maybe that's going to be the result. So you update the whole document each time. So it's just another way of approaching the problem. But you can't really do it with the traditional transactions. Inserts and updates are only atomic at the document level. That means you can add and remove a document, but individual updates and things like that then are not necessarily tracked that way. So you can replace a document or get one out or remove it or whatever you want to do at that level. It's not suitable for scenarios where complex transactions. Again, transactions are not supported. So if you have something that says, well, I have to update this table and this table and that table before this thing is going to be completed correctly, then you won't be able to do that. However, you might be able to put the information from all of those tables that you need into one document and then just update that one document. So there's another approach to being able to handle that. It does not support joins in collections in the traditional sense, but sometimes they don't really need to do that because everything might be in the document. It's kind of a string storage because JSON really breaks down to a string, so it doesn't really support multilingual support very well, and it doesn't correctly sort strings in some languages. It just stores what you gave it and looks after it for you, and you can retrieve it. But those more complex type operations are not exactly supported. So they may be considered limitations, or they may be considered it's just a different approach to storing data. And a lot of the NoSQL family is sort of like this. There's no transactions in Redis, and some of these things would apply exactly the same way. It's just a different approach to storing data, and it may be a suitable approach for your application. So that's really how you would tend to look at it. Use case. Well, one of the things here that's quite important is real time, and Redis falls into that one as well, is that it's very fast. It's typically faster than a traditional relational database. And in fact, it's in the family with memcached, which is essentially a cache, right? So it's very good for that. It's good for content management systems where we retrieve documents after conversion. That happens inside. We don't necessarily see it. We see it in the JSON format, JavaScript object notation. And these can be directly rendered at the web layer. The JSON protocol, or the object notation, can be turned directly into a JavaScript object, and it's very quick. Whereas traditionally, when we were using XML, then we would have to parse the XML in order to get that to the format that we wanted it in. And oftentimes that it didn't, it was kind of slow. It's noticeably slower to do exactly the same application using XML as it would be in JavaScript object notations. I've done it. So it's very good for high volume and throughput of data for websites. There's a lot of things are happening very quickly. Maybe we want some persistence, and maybe the speed is more important than anything. So there's a lot of sort of data going directly. It's also quicker to make a change to something in the application because we don't have to rebuild tables and change schemas and things like that. So if this is what you're trying to do, it's possibly a very suitable platform to be using for that. So the server-side infrastructure, you could use it for geospatial indexes and applications that require real-time inserts, updates, and queries. So I have to work on some stuff that's pretty quick, and so something like Mongo is a good idea because it's much faster for doing the retrieving and accessing of the data. So if I have a lot of data or I need it very quickly, it might be a suitable candidate. Agile development and fluid business requirements. It's a dynamic data model concept lends itself to the idea that we may need to make a change, we might need to add another field, and we don't want to have to go and change a lot of tables and rows and rebuild the database and stuff like that, like we might do with an alter table in a relational database sense. So that doesn't really exist, and beyond that is the migration systems, if you've used those, where we may change several things and then update all the database tables and rebuild a bunch of things. We want to add a new field to the document. We just put it in and it gets stored along with all the other fields, and that's just about it. So we can change things quickly. It means it's probably good for prototyping as well, because in the process of prototyping or agile development, for example, we might have to change things quite a lot while we're doing it, and that it's much easier to change them, much quicker to change them, so that speeds up the development process. Superior big data experience is delivered at any scale, so lots of data and putting it in and analyzing it. Again, it's very, very quick for doing this sort of thing. It has its own query language. It would need that. Relatively intuitive and easy to use. And the MongoDB query language in the various drivers. Slight variation. The driver is really the client, or we call it a connector, database connector. So you might have one for C++ or one for Python or one for Node.js. And sometimes the implementation will be slightly different there. There's some slight variations, but for the most part, they're doing the same thing. They would return something more specific to the language. For example, in the case of Java, they'll return a Java-specific iterable interface to navigate, whereas in Python, you might get a Python iterator, but it wouldn't be the same as the Java one. It's just adapting to the language platform that it's going to. To retrieve a document from MongoDB, you can use either of the two following methods here. The find, the most common one, that will return an iterator. Iterator means basically we're not going to give you all the data, but we're going to give you like a cursor. If you have a cursor in SQL, so you have something that you can use, say, okay, give me the next row, give me the next row, give me the next row, and it just does what it needs to do to fetch that at the time that you make the request. It doesn't just go and get all the data and return it all at once. So that's how that works. So find does that. Find one, of course, is like I'm going to limit that to I only want to retrieve one, in which case it can return that one. So it's a slightly different interface. And if you know you're only going to get one row back that you want, you would use that, and then you wouldn't have to step through your iterator, but you would only receive one row at a time, or one document, to use the proper terminology. So Mongo supports full set of CRUD. What is this CRUD? Create, read, update, and delete operations from traditional database. And those are the things you would normally do to a relational database. And they've also extended that. So there's some additional ones. So these are the traditional ones that you might see. Create, that means add data to the database. Read, fetch data from the database. Update, make changes to something that's there, a document that's there. And delete a row from the database. But they also have some additional things that you can use, like count, replace, aggregate, distinct, bulk, one or many, and find and modify. So they have some additional functionality that can be used for doing it beyond what you would do in a traditional, say, relational database. So here's an example of using the find method. So you have a collection, and that collection is what you're going to be querying on. That's where your documents are stored. You can have multiple collections in the database. So do collection.find, and then we give it a query and something called a projection, and this kind of comes over from the relational world as well. So let's see what these are. Well, the find method is similar to select in that it returns rows. Now, it's going to return an iterator, which is like a cursor, right? So to produce a well-formed JSON document for output, you might use the pretty method on find. And JSON, when it arrives in your browser and you're going to use it, it can be just like a bunch of trash. As long as everything's there, it doesn't matter if it stretches over one line or it's not easily human readable. So they've provided a method to make it sort of line up nicely so you can read it. Turns out I got into that with some other databases, and I'll often go into my browser and fetch some JSON data from the server to take a look at, and usually it's spread all over the page because it's just, here's all your stuff, you know, and so what are you going to do with that? But there's a plugin for the Chrome browser that kind of pretty prints all that JSON, and it lines it all up nice so you can read it. I forget what it's called, but I've got it installed here, and it works quite well. So that's really what we're talking about. It's called JSON Viewer. Awesome. That's what it's called. So they have that built into Mongo, so you don't have to worry about it. You can just say .pretty. So the query parameter corresponds to the where clause, telling it what you want to retrieve, and it will contain attributes of the underlying document used in the search predicate. So you might put in it one, you want to look for a particular ID, you would put the ID in there, and it would return that particular one, in which case you probably use the find one. But you might put, you're looking for all the people on a particular street. So maybe you would put in the street, and it would find all the documents where the street matched the one that you put in. Okay, so that's the kind of way that you would approach that. Projection, again, is similar to the projection in relational databases, and that is you can tell it which field you actually want to return. So maybe you have a document in a collection and it's got 100 fields, and you only want maybe 10 of them. You can specify the ones that you want. So that operation, traditionally called projection in relational theory, and they support that here as well, so that you can retrieve only the columns, only the fields or columns that you want to see. Find one, again, very similar, except that it only returns one row. So most of the drivers then support this this method. So if you have it without parameters, it'll just return find will return all the documents in the collection, but find one probably just returns one document. So this is, for example, we'd like to have all of the documents from year 2000, and so we're using find. So we get back then as an iterator. That iterator, we can iterate through it and get all of the documents from year 2000. Find one is similar syntax, but returns only the first document matching the query. So you'll get the first one from the year 2000, not necessarily the first in the year. You've only asked for the year, but the first one that it found that matched your criteria, and it will return that. And so it probably internally goes to find and says, go and find me all of these, but just give me the first one and return it, because it's an iterator. So find builds iterator. We iterate it once, and then we return the payload, and we've got the result that we want. Okay? So lots of times you only want just one document, and you want to get it immediately. So here's a little bit more of a sophisticated example for MongoDB query language. In the script that we're going to look at here, MongoDB is interactive, and it's kind of JavaScript-based shell, so it's similar to JavaScript. Fetches all the employees at job level 7 who earn wages in excess of 90,000, and we're going to order it by salary in ascending order. So here's the first part of find we saw before. So this is db.employee, that's typical. So that's the employee collection. Find, and then we're going to give it an example document. So that's what that is there. So job level 7, salary greater than is one of its operators, 90,000. Okay, so that's kind of an example document. And then we're going to tag on to the end of it. We'd like to have that sorted by salary, and the one indicates ascending. Right? So we want it in ascending order. So that's a typical kind of query that you might do with MongoDB. You want to do that in SQL, select star from employee where job level equals 7 and salary greater than 90,000, order by salary ascending. Okay, so that's kind of the functional equivalent in the traditional database approach. So it does provide excellent capability for ad hoc query support, and usually it's sort of done kind of like by example, if you want to think of it that way. It's being done by example. I have a question here. Sample examples, a practical demo. That one's not practical. Further variation on that? Don't want to retrieve employees? Can you elaborate on that one a little bit more? Okay. Yeah, there's no actual UI for Mongo. It's only command line. So you're actually typing this on its command line. So there's no graphical interface to it at all. If you have a graphical interface, it's probably because you went further into the mean stack and you built a web interface for your application, and then you have Mongo in the background retrieving the data. There may be some sort of third-party things that do this, but fundamentally Mongo itself is a command line, or basically you connect to it on a local host on a port and interact with it that way. To do an insert, Following command will perform an insert, a simple document to our collection. This is our user collection in the DB. And we're providing, in this case, this underscore ID. And the underscore ID is our primary key. And if we provide that, it will use that primary key. If we don't provide it, it will generate one because it needs a primary key to keep it unique. And then we can add any other fields that we want. We want to add when it's created, and that's actual JavaScript there, new date. And it'll just generate a new instance of date, and it'll put it in to the created field. So that row has an ID and a date. That's all that's in it. And we can add things to it later if we like to. Okay, so let's do a little bit of a comparison with MongoDB and Apache Couchbase. I've done some work with Couchbase. There's a little bit of different. They're doing a lot of the same stuff, but you can see the first part here, the consistency and partition tolerance and so on. That's pretty much the same for both. They're both essentially modern-day object databases. So MongoDB focuses on dynamic queries of constantly changing data, whereas Couchbase actually works with occasionally changing data and predefined queries. And so what you tend to do with Couchbase is you build a query function and you store the function and then you access that. So for things that you're going to sort of do regularly, it's pretty good for that. So not so much creating an ad hoc query, but instead creating a little script that you store in there and say, okay, give me what that script returns. Okay, so Bison takes more disk space than plain JSON, but it's easier to traverse. Couchbase uses plain JSON, doesn't incur the overhead. There are advantages to both approaches. Mongo offers a simple data query API. MapReduce syntax also supported if needed. Couchbase lets you write queries as a map and reduce function. So that's really their main approach, is doing it that way. And it's a bit trickier to learn because you have to learn their syntax for doing that. And then you essentially store those queries and retrieve against them. Mongo supports master-slave replications. We talked about just a little bit earlier. Couchbase will actually support master-master data replication. That's more complex, but if you need that type of approach, then you could do that. But again, as I mentioned, sometimes the parts of the mean stack, as we call it, can be interchanged. You may find that Couchbase was more suitable for your application. Well, then it would be keen instead of mean, but it's still in the spirit of what we're doing. We have a database, and we have a web server, and we have a front-end web framework, and Node.js is going to probably be there either way. I think Couchbase might have its own server side, but you still talk to it in a similar way, and there's still connectors, so that stuff's pretty much the same. So that's what I have for you on MongoDB. So we had a look at the main features of MongoDB and the fact that it has its own query language, which is expressive and easy to use. And one of MongoDB's competitors, I guess, is CouchDB. Let me just sort of show you where I've got Mongo running here. So I can find the right window. I will sort of quickly show you. There we go. So that's the server running there. I started it up somewhere here and just gave it some parameters. I gave it a port to use and told it where the data was stored, and I just leave it running. Now, you would run this on a sort of on a production system, probably as more of a background process, but you can run it in foreground if you're doing development and testing. So let's move on to the client. So they have the there we go, the Mongo client. So this is where you can access it from the command line as well. And what I've done here is I've created a to-do database. We have a to-do application. And I've just gone ahead and inserted, I've just saved these things into the database. So I put 3 to-dos into the database. And then I went ahead to do a query. I just did a todos.find, and it returned, oh, one of them didn't like, which is odd. So I thought, but anyway, that's basically how you do the query to get the results. And you're saying, what? We have to do it on the command line? What happens is your program talks directly to it, probably your back end, whatever the back end is, and at that point, you don't interact with it on the command line. Okay, I got some questions here. How to design a database? Well, there really isn't a design. You just sort of store data however you like and change it if you like. I know I felt the same way that I can tell you're feeling. Is it, wait a minute, don't we have any rules? And don't we have any data modeling? And no. But if you think about where it's most often used, we've got a bunch of data on the screen and we want to store it somewhere and fetch it out later. It's pretty good for that, but no schemas, right? Anything like that. Okay. The only one who can't access the above link. Okay. You should be able to do that. In fact, I just clicked on that now. And it should, whoop. It should come up like this. It's a PDF file. You get redirected here, but if you use that link, it should get you there, because that's how I got it. I just pasted that link in there for you. Okay. Where is MongoDB used the most? Oh, that's a hard question. The only way I can say is that if the architecture of your application is suitable for this type of data store, then that's where it would be used. Not all are. I guess one of the ones that I work on is a building lighting control system, and it's kind of half and half. I have some volatile data, which is basically the state of all of the information, and we query that and we look at it and we look at that data. And then we have, in addition to that, configuration data, which we program, and we say, well, what floors and what zones and what lights are in them, and that doesn't really change. So we tend to use a relational solution for that. But we can actually use the two sort of side by side. We want very fast access to the real-time data. We need some of it's real-time, and fast access to the volatile data, like there's a light on or off. All we have to do is start up and read the lights, and we know what it is. So it's kind of more like a caching thing. But you can put more in it. Depends on which way your application leans. There is no schemas, so it's just documents and collections. That's pretty much it. You have to be diligent. If you want to do that, you can do it. Mongo has not precluded you from doing most of the things that you would do in a relational environment. It's just that you have to do them manually. They don't happen automatically, and you have to be very diligent about it and follow the rules. And if you don't, or if your programmers don't do that, then they can make a mess. That's pretty much the way it is. MongoDB is safe and secure to use for e-commerce. Oh boy. I'm not going to comment on that. I think I'm going to refer you probably to the Mongo website and see what they have to say about that. But I don't think that it's much different, except for the fact that the sort of integrity layer is not there. But they still run on the server, and the same server security mechanism would be in place as you would with a relational database. So other than that, I would probably check with the Mongo website. Any other questions before we move to the next section? Some questions there. Okay. So it looks like we're going to move from here to Node.js. I'm just sort of doing them in the order that they were in the notes. I'm actually going to clear the questions so that I think I've answered them all. If not, just ask again. And the reason being is that I can see if a question comes up. So I'll just sort of do them in the order that they are. It's like M, N, no, they're not in alphabetical order. doesn't really matter because this is one that we're going to sort of get into straight away. Now, to work directly with Mongo and use the command line and use the connector in any language, you can still do that without using Node.js, but to move on from there, you're going to start using Node for pretty much everything. So what the heck is it? Well, it's JavaScript. JavaScript. Very important. And the reason being, there's a lot of people that say, well, I want to use Node.js, and they don't have a strong background in JavaScript, because that's really what you need to know. And I can remember a few years back, I watched some of the presentations that come out of software development conferences and things that they have around the world. You can pick up some of those on YouTube, and they're quite interesting. And I remember this guy was giving a presentation, and he got up on stage. He said, we had a really good idea. We're going to take the JavaScript engine that runs in the browser, right, which is actually open source, and we're going to run it on the server. And I can remember watching a lot of people saying, what are you going to do that for? But I got to tell you, it absolutely took off. And in just a couple of years, there's so many packages for it. There's so many things you can do with it. It's almost very difficult to develop any web application in some of the modern front-end frameworks, React, Angular, almost any of those guys, without using it. And you'll see that just to do the management of your development process in and of itself is something that it makes very good use of. So let's see what it is. We'll dig in a little bit. What are its core concepts? We'll understand that it is an event-driven non-blocking I/O. This comes from JavaScript. Okay, so that's the way the JavaScript engine works. How is concurrency supported? We'll just have a look at a very simple application, the traditional hello world, and we'll introduce the package manager. Node package manager, well, I'll get to that when I get to it. The package manager used for Node, which is sometimes called NPM, but they say that NPM doesn't actually stand for Node package manager. It doesn't stand for anything. That's what they say. All right, so let's move in here. So this is their current goal, is to provide an easy way to build scalable network programs, and that's kind of what they want to do. It's a platform for building high-performance JavaScript applications. JavaScript, again, very key. It's built on the V8 JavaScript engine from Google. It has a just-in-time compiler that compiles JavaScript to more native opcodes for performance, so it's kind of like Python in that way. It's single-threaded. Again, that's an important thing because JavaScript, as it runs in your browser, really is used largely as an event handler. So for instance, somebody's going to click a button, or they're going to go to a field, or they're going to hover, and this causes an event, and the JavaScript engine fires up and handles the event, and then it's done. And so it's a single thread. It's very fast, but it can't get stuck in a do loop. It has to complete and pass on. And the same architecture is carried into Node.js as well. So your Node.js application runs in exactly one thread. You can't have multiple thread applications. You can have multiple Node.js servers if you want, but it's just one and only one thread. Now, it turns out there's some advantage to that in terms of sharing of resources, because you know if there's only one thread, there are no two threads accessing the same resource at the same time. So you don't have to program around that. So it's a kind of an advantage. So if you want to use multiple CPU cores, or if you have multiple processes that are happening, you can actually run multiple processes and make that happen. Okay? And sometimes we need to do that. The other thing we do a lot of, it's not mentioned here yet, that comes along is the idea of a callback. So coming down through this main thread, we have to do something, and it's going to take a finite amount of time. We want to make sure that, that we don't hold up the main thread, so we'll farm it out, and then we'll get an event or a callback when that happens. So that's kind of the architecture that takes place. So event-driven, non-blocking, file and network IO, so it has both of those. So you don't keep the application thread waiting. You can't tie it up because your application will stop. This is true if you're writing a web application in your browser using JavaScript. Exactly the same architecture, and it works exactly the same way. And so we can process many concurrent HTTP requests using a single thread, just like one after the other, and it works just fine. It's just another approach to this type of thing. The package manager, called NPM, often referred to as the Node Package Manager, allows you to manage packages, create packages, and download packages. So this is sort of the, I want this package, but that package uses that other package uses another package. You don't have to worry about any of that. Just say, bring this one in, and it'll bring all of the dependencies in. Okay. Main website, Node.js.org, and you can go there and take a look. So Node.js is, as I said, is really taken off on the server side for web applications, and not only for using as a server, because again, it's kind of like Mongo, and it has specific places where it's a very good fit, and other places, the more traditional type backends, where it's not as good a fit for that. But definitely for development tools, for testing, for pre-processing, for building stuff to be delivered to the web, and there's dozens of things that are done using Node.js. So it has fairly good performance, and it's really jumped into being used for a lot of things. Both the client and the server-side code is developed in JavaScript. Now, as it turns out, that may be an advantage, because as a programmer, you don't really... Someone's sort of breathing down right now. If you wouldn't mind muting your microphone, that would be appreciated there, because we can hear you breathing. Okay. So if you're a developer and even... Must be on the phone, I guess. Don't know. Okay. All right. So if you're a developer, and I'm a developer, I often work in different languages, and sometimes you can easily get confused and use the wrong part of the language. I say JavaScript and Python are pretty close, but sometimes too close. So the advantage of this, you work in the same language on the front end and the back end, and you're full stack, you're doing both, then you're only working with one language. So that can be an advantage. Performance, generally much better than things like PHP. Not as good as other things that are sort of pre-compiled, but depending on what you're doing, it might be the right fit. It's also used to write command line tools. This is the other thing that I mentioned. Command line tools that are used for building front end for websites. So some of the things you might have heard of is Gulp, Grunt, Jasmine. Maybe you've heard of those. I'll add a few more to that. Babel. Babel's used for translation. TypeScript, TS, converting TypeScript. Webpack, which is what's used in this example here. And Browserify. There's all kinds of them that many more that I can even mention. But the idea is that you have Node.js on your development system, and you just have something that you need to run. This Gulp and Grunt are task runners, so you can run a bunch of tasks to build your application. Jasmine is testing, and Babel is a translation, so ES6 translation, and React. If you're using React.js, you can do that with Babel as well. Okay, so these kind of tools that you might be using to build your front end can run under Node.js, and it maybe gets even more use that way. I'm not sure which is the largest usage. So you may need to learn Node.js even if you're using your backend is in Java or using .NET or something like that in the backend. You may still use it in the front end for building your front end applications. It's being used to write great-looking desktop applications using something called, it's on the tip of my tongue. You've probably heard of it. It's gone now. Anyway, you can actually write desktop applications using this toolkit, and they look like regular applications, and it's kind of cross-platform. I remember that. They didn't give me the name, and I don't remember the name, but I'll think of it. I'll let you know. But you just say, okay, JavaScript desktop applications. I'll give you the name just so you know. And the answer is Electron. That's it. It's called Electron. So if you want to write a desktop application, you could write it in JavaScript, and you could use Electron to make it work. Yeah, somebody's got it there too. Well, Google knows everything, right? Wonder I can use. I've seen it many times. It just disappeared. Okay, so to install Node.js, if you're on a Red Hat system, if you're on a Red Hat Linux, they use Yum, Yellow Dog Updater Modified. Originally wasn't Red Hat, but they used to have the old RPM. You had to do everything with RPM. I worked with Linux for quite a few years, and now they have Yum. Yum is kind of like getting the application that you want plus any of the dependencies, so it's kind of similar to NPM, isn't it? Right? And so that's how you would go through it using Yum. You might bring down what you need and have Yum install it. If you're on a Debian, I'm going to say Debian because Debian is really the root of this tree. Debian Ubuntu. Ubuntu is derived from Debian, and there's a whole bunch of other ones. So that's the apt-get type interface. Apt-get update, apt-get install, Node.js, apt-get install npm. Usually they come together, but they may be separate, depends on how it's been packaged. And this is kind of an important one if you're working on that environment. And I'll explain what that's for, just in case some of you happen to be using a Debian Ubuntu. They actually have something on there called Node, and it was already there. And so they didn't want to make Node.js into Node because it would be a conflict. You may not even have it installed, but what they ended up doing is calling Node.js, which is usually called Node, calling it Node.js. And it turns out that doesn't actually work, because when you start to run it, it gets called by other packages, and they don't know any other name except Node. So the fix for that is to convert the name by putting a symlink into user bin. So then when you type Node, you get Node. That's a little bit of a fix that you might have to do on the Ubuntu Debian type systems. There's also installers for Windows, Mac OS X installer, and after the installation, you can verify that it's up and running. And let me see, what am I talking to here? Node version. We have newer ones. This is, I think, the latest one that's it comes down when you load it down. Where are you here? There we go. Okay. So I just said, okay, what version am I running here? And this is fairly recently installed, but it's 6.11. But we do have Node 8. Okay. We do have Node 8. That they're working on now. So I think this might be the latest stable one. Anyway, that's what you get right now. Okay, so the question, can we get this recording? Check with WebAid Solutions. I believe they may be recording this, so you'll have to see what they have to offer there. Just check with them. Okay. Okay, so I just ran that Node version to see what it is. So I happen to be running 6.11.4 here, and I think that's sort of a relatively recent one. So let's do a Hello World application. But instead of doing right on the console, which you can do, by the way, just console.log, which you do in JavaScript, do exactly the same thing. Only what we're going to do here is we're going to make a hello world that's a web interface, right? So we can do that. So we're going to use the package HTTP, which is a fairly low-level web interface type package for Node.js, and this is the entire application here. So http.createWebServer. So we're going to require first. Require says I want to use this package, and it will fetch that package in and make it available. The module package that they're using on Node.js is kind of similar to Python, and it's sort of the similar structure that they're kind of planning to do on the web side, on the client side, but that's not completely nailed down yet. So we still have a little bit of fluctuation going on the browser side, but in the Node.js side, we say this is what we want. So then that creates an object called HTTP, and we can talk to that. Create server, and because it's a server, it's going to wait for connections on, in this case, port 80. It's going to listen on port 80. And when it does, it's going to execute a function. Some people might find this a bit nasty, but what happens with Node applications, in fact JavaScript as well, is that this is a callback scenario whereby it's going to sleep and it's not going to use the main thread until it gets an interrupt or it receives a request on, in this case, port 80, and then it will fire up a callback. Now what we've done is we've passed the callback in the form of an argument to the create server. Now you can actually create the function somewhere else and just pass it by name to create server, but this is common in JavaScript where they just stick the whole function right in the argument list, and that's it. So we're defining a function. This is a callback function. It receives request and response, and all we're going to do is write out our content type, write out our hello world, and then we're going to tell it that's the end. So then when we run it, we just say node hello world.js, and we go to this location, and it should just print out hello world on the screen for us. Is there an HTTPS package as well? I'm not sure about that, because generally we don't do it that way. What we would tend to do, and this is what I tend to do, is use something like Nginx or Apache that supports all of that, and put that at the front end, and then proxy to your node processes in the back end. And I do the same thing with Python, so that kind of architecture is usually common. But you may find that there is a package for it, not the standard HTTP that comes with it. Right? But that's often how you do it. So you take a front-end web server here, and the other thing is that you might have assets that you want, like static assets, and you serve them directly from there, and then you just do a reverse proxy to a node process or multiple node processes. Okay, and the web server can do load balancing and other things like that. So that's often the architecture that would be used. We use it directly. Don't know, haven't done it that way, so it may be possible. Or you can certainly use it at HTTP directly, but I don't think HTTPS. But doesn't mean there's not a package for it. And likely that if there isn't one, is by the time I'm finished talking here, it's going to be one. So just look for it. Do a Google, you might find one. But I would probably recommend putting a front-facing, traditional, more secure type, more battle-ready type server at the front. So how does it work? Well, I kind of explained it already, but I'll just quickly go over it again, and that is we're going to require HTTP, which is the HTTP package. That's a pretty standard part of Node.js, and there are some standard things that are available. So we're going to create server. We're going to pass it a function. This is a callback function that it will call when it receives a request. We're going to tell it to listen on port 80. Okay, so then when you connect to it, and this would be localhost port 80, then when it gets your connection, it will invoke the function, and the function will write back to you content type headers. It will write hello world, and then we'll end, and the connection will close. Okay, so that's just a very simple web server. Okay. So the benefits of being built on JavaScript is JavaScript is the most widely used programming language in the world. You're going to say, really? Really? Why is that? Because it runs in every browser. And so every single browser on the planet runs JavaScript. So in that case, it gets that label. It's the language of client-side web development, and you can use the same language on the server. As I mentioned, that is sometimes an advantage. I know that I've been writing some Python, and I've written some JavaScript into it. No, that's not going to work. So it's good for that. It supports JavaScript object notation, both cases, because it is JavaScript, and it's the JavaScript engine. So the interchange format that's often used can be done that way. It does use this non-blocking paradigm common in JavaScript, and therefore you have to kind of think a little bit differently, and that means you're going to farm something out and expect a callback. That callback is going to be used to handle the fact that you've got your results back, where there's a single thread that goes down, we use it, and then we release it, and we don't hold it up, because if we hold up the main thread, then we can't get anywhere. Okay, so somebody's found an HTTPS implementation. I'm not surprised. But there you go. It's Node.js.org's API https.html. So there you go. Generally, I don't use it that way, but it's apparently possible. So in the traditional server-side I/O model, and this is one of the things that changes when you start using Node.js. If you're using Java, C#, Python, any of those other things, it's synchronous and it's multi-threaded and it is blocking. And so what tends to happen is, here's your web server, and then the web server will spin up a number of workers. They call them workers. And usually that's configurable in the web server, and you get a request, and it will pass it to the worker, and that worker will in fact block, and it might go out and query the database and get your data and do whatever you have to do, and then when it's finished, then it will return to you, and then the worker becomes free to accept another request. So that's the traditional architecture that's used. So that's synchronous, and that is that it runs to completion and then it goes back again. Multi-threads, so each of these workers is a separate thread, and blocking the thread itself will block to handling your request. And of course, once you run out of threads, you get over here, then you're going to wait for them to make the connection. Okay, that's when your web server gets slow. So that becomes a tuning parameter. So this is apparently some Java code showing how that works. You might do a select and get the connection and get the result, call the query, and then build the result into some result and send it back. So all of this code here then will run in one of these workers to completion, and then when it's completed, it will return and free up the worker to take another connection. Okay, so that's a traditional approach. So some of the disadvantages, they say that some people are afraid of multi-threaded applications, but I work on a rather large one, but I guess that's just me. Threads block and wait for a response. You can actually run out of workers, and they can't do any work while they're blocked. That means they're maybe waiting on a large database query. That could happen. And so then they get the results and format the data and send it back, but they are blocked. And there would be a fixed number of workers. Usually we give it, it's a tuning parameter, so we can give it more or less. And they are sort of fixed threads that are available to accept requests. And once we go past that, then we have to wait after that. So each thread has resources, stack memory, and so on. So you're effectively creating kind of a process, and it has resources that are being used, unavailable while it's blocked. Improperly implemented threading can result in some race conditions or deadlocks. If you're talking to a database from 2 threads, and that database is not necessarily set up to handle multi-threaded access. So you start getting into something like Mongo. I think Mongo is okay that way, but some of the other ones aren't. Then you can cause some difficulty. Even if it is capable of handling multi-threads, these guys could have some sort of a collision, and so that's a possibility. The idea of the event-driven non-blocking I/O is that no blocking calls are allowed to run. So if you have network I/O and you're waiting for something, that thread is released and it's available for someone else to use. Disk I/O is the other thing that takes time. Database calls, so we can't just say, okay, go and read this block on the disk and I'll wait till you get it and then give it back to me. Can't really do it that way. We say, go read this block on the disk. Let me know when you're done. And then the thread gets released, goes off and does something else, and then there's an interrupt or a callback, as we call it, that happens a bit later, and then it picks up where it left off. Okay, I got my disk block. I'm going to go ahead and do what I need to do and send it back to the client, and I'm finished. Okay, so that's the approach that they take. And it's a little bit different than traditional, but it does have some advantages. It's just a different architecture, not necessarily better or worse in either case. So we'll have a function, which is referred to as a callback. And the caller doesn't block until the event loop fires that callback, and then they get the thread back, and then they continue where they left off. So in this example, it's using jQuery. jQuery is a popular library used in front end. You're probably familiar with that. And what's happening here is that we're going to retrieve some data from the server at this URL. And so we're going to do a get. So this is how you do a get in jQuery to that URL. But when that's done, we immediately fall through and carry on with whatever's going on. So we haven't fetched it. We've made a request for it. When it's completed and it returns from the server, then we fire up this callback here, and that handles the results coming back from the server. Okay? And it takes people a little while to get onto that concept, but that's how it's done. Well, the same mechanism is in Node.js. When you're using it on your server, it works exactly the same. Oh, there's a question there. Let me see. Does Node.js support ES6? As far as I can tell, it depends on the version, and I don't remember the exact number. It's later on in the rest of this course. But the newer version does support ES6. I think 8 is the latest one, but I'm not sure whether that's released yet or it's still kind of underway. But it's definitely available for use now. Maybe you're running a beta version, I don't know. So Java app servers, again, use a multi-threaded concurrency model. So the server maintains a pool of threads, like workers, right? We call workers. And each connection gets a new thread, gets handled the worker. And that worker runs to completion for that. And then it just frees up and I'm ready to accept another request. Okay, so that's it. Node uses an event loop for concurrency. It runs as a single thread. And your I/O code actually runs different threads, but you don't control the threading directly. So they have their own way of doing things, and they report back when it's completed. Okay, so it doesn't run in the main thread. It is a very simplified programming model. Once you understand it and get to using it, you'll find that you have less problems with synchronization between things like especially deadlocks or race conditions. You don't have to worry about those in this architecture. Yeah, other things to worry about, but not those. So you're okay. The package manager, the traditional off-the-shelf type package manager, NPM as it's called. Basic usage commands, NPM help, so you just say NPM command, possibly options. NPM install a particular package. LS, list all the packages that are installed. Link, manage dependencies, and publish. For publishing, let me see if I got here. We got a list here. One thing I will say about Node.js, I'm just finding the top of this and I'll show it to you. You'll be surprised. Okay. Here we go. So I just did npm list here, you can see. And it's going to show me all of the things that I have installed and all of the things that they've installed and all the things. So I use Babel. So actually this is a Babel preset. And I'm not sure which one that is. ES 2015. So that's the ES6. So that's another way to do this, is you can always take, if you want to write an ES6 code. By the way, most of it is supported by browsers these days, but you can use Babel. You can look it up. Its main job in life is to translate ES6 to ES5. So this is a preset for ES 2015, or ES6 as we call it, right? And it's got, let's see if we can find something else. So it takes a bunch of things. I was using Homebridge. If you're not familiar with Homebridge, it's the Node.js package that talks to Apple HomeKit stuff. If you have Internet of Things stuff in the Apple domain, then there's a Node.js package for that. So I was playing with that for a while. And here's another preset. I believe this one is for it's another preset for React, because I do some React. There's some more Homebridge parts. JSPM, JavaScript Package Manager, another package manager for managing front-end packages, similar to Bower. So I've used some JSPM. So you can see that these are all additional packages that get pulled in and used by other things. You just type in, I want this, and it just brings everything in for you. Okay? So, but you can get quite a lot. It's now telling me that Homebridge is extraneous. I'm not actually using it anymore, and I should actually remove it. So I could do that. Anyway, that's just a quick tour of using npm. And to install something, just npm install, and it just goes and it fetches all the necessary parts and pulls them in. Express. Aha. We're just going to mention what Express is here. We're going to cover a whole chapter on it. The web framework built on Node. As I mentioned before, it's similar to Ruby on Rails or Django or things like that, but this one runs on Node, and it's fairly full-featured. It uses something called Connect, a core web server functionality, query strings, cookies, and so on, and static files. It'll serve static files. Works with multiple template formats. The most common one is Jade, is common used. Embedded JavaScript in it, and you can use it for RESTful services if you want, framework for RESTful services, or you can build a traditional web page that returns HTML page as well. You could do that using Express. So it's kind of full-featured in that respect. Okay, so we'll get to that, I think, next. Yeah, it's the next chapter. So just the introduction to Node.js, what it can be used for. Core and Node concepts. Event-driven I/O is an important one, and how concurrency is handled, and that the fact that there's a single thread and we use callbacks. And there are some advantages to that architecture. We saw a simple Hello World application written in Node.js, and a slight introduction to the Node Package Manager, whence cometh most of the packages that we need for what we're doing. Okay. Any questions at this point? Any additional questions? I'll clear the deck here so I can see when new questions come up. Questions? Okay, so I got about 20 after 3. Let's take about a 10-minute break, and we'll resume at 3:30, and we'll pick up at that point. Just go take a stretch, get a cup of coffee or something, whatever you need, and we'll just resume at 3:30, and we'll pick up with, at that time, Express. We'll learn a little bit about Express. Okay, thank you. Hello. Welcome back. I guess for people that might have missed the very first part, my name is Gwyneth. Gwyneth. People just call me Gwen. Spelled the same. It's pronounced the same as G-W-E-N, but spelled G-W-Y-N. Okay. So just during the break, I had a little look at the Mongo client here. So what happened, I was mucking around the ports, so it was on the wrong port. So here I've connected to the to-do database, and then I just did a find, and you can see it's retrieved the 3 rows that were, 3 documents that were placed in before. So yes, it does work. Just got to be on the right port. There's a sort of a standard port, and then you can change it. So the application here, they've chose to change the port, so I changed it on the server, but I didn't change it on the client. These port things, right? Okay, so let's move along. So we'll take a look at Express and see what it does. Just a little bit of an introduction to Express, how it works, how to define routes, what it requests, and how to create a response document, and how to obtain parameters from the requests. So introduction to the basic functionality of Express. As I mentioned before, Express is written in Node.js, and it's basically a web framework. It's a complete web framework, similar to something like Ruby on Rails or Django or some of those things where you can build your web application in it. And this is the one that's most commonly used with Node.js. However, I'm sure there's more. I'm certain there's more that you could use, but this is a fairly popular one. So it's a web framework built on HTTP module. So it's built on top of the HTTP module that we've already had a look at in the last section. And it provides the necessary features that you need for a larger web application. For example, routing. Routing means when you put in a particular URL, you go to a particular section to handle that request. It does templating. The most common templating library that's used with it is called Jade. Templating basically means that you can fetch some data and you can lay out your HTML page and it will insert sort of parts into it in the right place. So that's the traditional building of server, what do they call them? Active pages, that kind of thing. Okay, so it does support that type of thing. It does have in it static file sharing as well, because often you want to serve up images, for example, or maybe certain libraries, depending on how you've set your system up to be able to do that. And it has the ability to plug in things called middleware that provide framework functionalities like caching, security, logging, and things like that. So there's a number of middleware pieces that you can use with Express to get this additional functionality, or you could write your own middleware for Express. So to install it, again, now we're using Node, right? npm install Express. And I've already, if you work down that list a little bit further, you'll find it is in there. So I use it. And that's just what's on my system and the things that I've been using in the last little while. So this is quite a long list. And then to use it, again, we're writing a Node.js application, so we're going to use require again. And we don't have to require HTTP. And the reason for that is that Express uses it, and it knows that it uses it, so it's all automatically there. Okay, so we don't really have to do that. But we're going to create an app, and we're going to call Express. That'll return an application object. And then we proceed to attach our functionality to that application object. So if somebody does a get to /, then we're going to call this function and return hello world. I think so it's kind of similar to the one we did before. If they go /moon, then we're going to call this function and we're going to return hello moon. Okay? And then listen. This was listening on port 3000, but we can tell it whatever we want. Now if you compare and contrast that, what we did in HTTP, you see one thing that's going on here is that we have routing. That means we can do / and /moon and / something else, and we can set up whatever response that we want to provide for that route, that somebody requests that. So it's not just one, send back hello world, you're done. The other thing you'll notice is that we're using response.send here. We haven't had to set content type and things like that. It's handling that for us. So really that's what it's doing on top of HTTP, is it's providing additional default functionality to make it a little simpler to write what is essentially the same application that we wrote before. Okay? Now the difference is we have multiple routes, and it's a little bit simpler. And that's just using Express in its very basic form. So each route is a unique combination of HTTP method and path, so you can specify the method. If you look here, this is a get, and this is a get, but you can also do puts and deletes and things like that, so you can handle the whole schmear. So get, put, post, delete, supports them all. Whatever you need is all part of the HTTP functionality, and you specify what method is and what the URL or the path that's going to be used. So here's the case. We're going to do a put the customer, then we're going to call this function. It doesn't really do anything now, but maybe we're going to develop that later and have it provide the functionality for doing the put, return whatever we're supposed to do, and update our Mongo database if the case may be. Okay? See, it works very well with Mongo. You'd be calling Mongo from within Node and connecting directly. So request handler function is called when the request matches the HTTP method. So when you say /customer, then it will call that particular path. We'll call that function. Function receives two arguments: request, which is a request object, same one defined by the HTTP module, and there's also an response object, which is an extension of the response object for HTTP. As you can see, it puts in some default behavior that we don't have to do. Okay. The difference between put and post. This is HTTP question. Post, normally you're possibly writing a new record, and put, you're maybe updating a record. Not everybody uses all of the functionality, but that's what it's intended to do. It's just those things are a little funny because they're kind of laid out in the specification, but people tend to use them for whatever they want, especially things like put. But that's really sort of what it's supposed to be used for. Can we swap HTTPS under Express? Okay. Again, I don't do it that way. I put the HTTPS stuff in the outer server and do a remote proxy, reverse proxy. And that's how I understand it's usually done. If you had something else, if Express had middleware for supporting HTTPS or some third party produced that, you could probably set something up to do that. Pretty much anything is possible in this environment. You may have to write some piece yourself or hunt down a piece, but you could probably do it. But not generally done that way by anything that I've seen. And there's special cases where it would make sense, but that's it. Okay. If you had a very, very small IoT, Internet of Things, microserver or something like that that you wanted to run and you want to use HTTPS, I would be hunting it down because there's probably something that does it. A customized call function implement. Let me see if I can read your comment here. Implement it outside of this main program. Okay, I'm not quite sure. I'm just going to go back here. You can have any other libraries that you want, and you can import them or require them here, if that's what you mean. So like a library of functions. Yeah, you could put your functions in another library. You don't have to put them right here. So anytime you do a require, then you're bringing in another module. That module can contain any functions that you want. So you could reuse them, for example, in several applications. But for the simple one that we're using here, we haven't done it that way. Right? Yeah. Yep, you could certainly put them wherever you want. In fact, that's often done. I have an example here we might look at the end where they did the data management stuff, and they put that as a separate, and they reference it. So there's no restrictions on how you do that. Path routing. The path is provided as the first argument for an Express route. After the method, get, post, whatever the case may be. These are all gets that we're doing here. So you might have these three paths. The paths can actually contain regular expressions. So in this case, we've said slash dot star any string car end of dollar end of line, if you're familiar with regular expressions. So that would match anything dot car, so it's going to match that one. For dot car, that would match that one. So it's dot star anything followed by car at the end. But it doesn't match cars because it's CAR dollar, CAR end of line, or car slash specials. It won't match that one either, so it won't match those two. It's just a regular expression and pretty standard regular expression type functionality. So that's useful if you wanted to have one route that handles multiple situations. In addition to the methods in the response object is defined in the HTTP. So it gets all of the HTTP methods that we saw before and some we didn't see. The following methods are added, and all of them will terminate the response document for no more data. So that's what we saw using send. Then we didn't have to call end afterwards. We just say send, and it does sort of standard content header. It assumes that it's JSON. If we give it a string or something, it converts it to JSON, sets the content header, and then the response document is marked as completed, and when you call send. So it does a lot more stuff for you. That's kind of what's going on with Express. It's easier. You don't have to do all the stuff manually, right? So you do a redirect, you pass a path, then it's going to respond with a 302 and a redirect, and it'll send your browser to wherever you've asked it to redirect to. Okay, so there are more sophisticated responses that you can use, and it saves you some work. So that's really what it is. It's a framework to make that stuff a little bit easier. So you can supply variable patterns in the URL in a couple of ways. The traditional RESTful interface, and REST is a technique that's often used for retrieving data, representative state transfers, what it's called. And the idea here is that you might say, I would like to have something like this. A more typical one is you want to have this and maybe a variable part, and still planets and another variable part. Often that might be a row number, that's sometimes, or like a primary key. Earth and Mars, I guess, could be a key. So when we code that, we say planets, and then we say colon in here, and then we give it a variable name. So we can retrieve that by going to rec.params.name, and we can fetch that. Okay? So that's a typical RESTful type interface. The other way to retrieve things is by using query strings, and that's the traditional. We're going to use a question mark, sort by equals something, so that's the query string type. And we can retrieve that in a similar way, so we don't have to put any special path part here. We just say rec.query.sortBy, and then we can retrieve the value of the query string. Okay, so that is there. So it supports both of those traditional ways of passing additional information to the server, either the RESTful part of the URL type or the traditional query parameters that can be passed with the question mark. And of course you can say question mark and more. So when a request is received by Express, it looks for a matching route in order that they are defined. So the way we laid them out, okay, so the first one here is planets, and this is planet/stars, all planets, and then planet's name. That's probably not going to work very well because it matches both. It's only going to execute the first one that it matches, and then it's going to leave. So if we wanted to do something like that, we'd probably put these in a different order. So we get the first one, a specific one, and if not a specific one, then any one, then we'll return something specific. So we probably put these in an opposite order. That would work perfectly, right? So you must need to invoke all matching routes, then you have to call the next function. So if you wanted to step to the next one, then you just call the next function. Yeah, I got that, and I looked at it, and I didn't like it, so move on to the next one. And so that's how you tell it, just by calling next. So if you have a catch-all, often put this at the end. Maybe you want to have something picked up. So we're going to do customer request for a path, irrespective of the HTTP method. So we're going to use all. So this is any method. Right? That's put, post, delete, anything. To customer, then we're going to just return some information. So no matter what you do, we're going to get that back. So you can define a route that will match any path and any method. So you can say all, you can say / anything. And then you put that one at the end of your list. So if you got all the way to the bottom, instead of getting an error, then you say, okay, I'm the last resort here. This is what you get. We didn't match any requests. So, and sometimes you want to do that. So they have fairly sophisticated mechanism for specifying routes and redirecting and catching certain data input in different ways to pass parameters. So they support all of the traditional HTTP stuff that you would expect to be able to use. So here's a full example web service using Express. We've got some planets. So this is, in JavaScript, is an array of objects, an array of JavaScript objects, and the planets array contains 2 objects, in this case, the Earth with 24 hours in the day and Jupiter with 9.9 hours in the day. So those are 2 fields that we have. So what you would typically do in a RESTful interface is if you go /planets, then you would just return all of the planets. Okay, so you go /, you get them all at a specific one. So what's happened here is that we've just passed the planets array to send, and send says, that's a JavaScript array of objects. It'll convert those to JSON. It'll set up the appropriate headers, and it will return the entire planets array to the client, and it will close the connection. Okay, so that's pretty easy to do. If you want to fetch the planet by a particular name, then we can fetch the name. So once we've got the name, we're going to set our result to planets.filter. We're going to test for the name, and if the name matches, we're going to return that one. If we didn't find any, return a 404. Otherwise, return the first result that we found that matched, because that's probably only going to be one anyway. And at the very bottom, we're just going to listen on port 3000. Okay, so, and that's a typical RESTful type interface where, okay, planets, get them all. Planet/Earth, get Earth. Okay, and that's the kind of interface that we would typically talk to. And what we get on the other end is a JSON string, which then gets converted to a JavaScript object, which then can be rendered in your browser using maybe Angular. Okay, that's coming up very shortly. So just to finish off with Express, as we can see, it's a framework built on top of HTTP, which allows us to build larger scale web applications. It supports pretty much all of the standard HTTP stuff, and it's a little bit easier because it does a lot of things for us. You can attach a different request handler function for each route unique combination of URL and path, so you can set it up to do what you want. So the routing is the major thing that's built in. So when you define a route, you can specify the path as a fully qualified string or a regular expression, and you can use a JavaScript regular expression notation to do that. The request handler function receives request and response objects, and these objects have extended functionality that was not available in HTTP module, we talked about before, and allows you to do things easier. You can just use a send, and it handles things we had to do in 2 or 3 different steps before. So that's what Express will do for us. Any questions before we move to the next section? Okay. So the last piece of the puzzle. What is Angular? We're going to introduce Angular JavaScript framework, see how to install it, and just a very basic Angular application. So what is Angular? kind of have to talk about this here. So you've probably heard it, and you've heard of Angular for a long time, but we're talking about now Angular, which is not Angular. Well, I know it's very confusing. But they used to call Angular Angular, and then they came out with Angular 2, and Angular 2 is kind of somewhat radically different syntactically from Angular, or Angular 1X as we used to call it. But then they decided to change the naming as well. I think this will come up a little bit later, but we'll gloss over it then. They said, well, we're going to call Angular 2 just Angular, and then we're going to have a new release every 6 months with a major number. So it was 2, and then it was 4. And where did 3 go? Well, apparently there was some conflict in packages, so they just skipped 3 and they went directly to 4. There wasn't much change in 4. So we're on 4 now. Actually, I think 5 is due out any time now in the fall. They'll come out with 5, and then they've gone to semantic versioning. So what is it? It's a client-side. This is runs in your browser, web development framework, and you can actually reproduce almost all of the traditional web interactions. So you could build a whole application that works just in the web page itself. You can do some of that now. It's based on JavaScript and builds on HTML and CSS. It's maintained by Google and a community. It is open source MIT license. So it's called Angular.io. The original Angular 1 has now been renamed AngularJS. But there's a whole lot of stuff out on the internet. When you say Angular, you're going to not be able to tell what you got if you go do some searching. But if you go to their website, this is Angular. I like to call it 2+, because it's 2 and beyond. 2, currently 4, soon to be 5. Okay. There's also a GitHub repository for it as well. So this is the latest and greatest that we're going to talk about here. So the main features of Angular. So what the heck do we need it for? We've got the Express. Yes, you can use Express and build static pages with server-side includes and do them in the traditional way. But when we're working with Angular, what we're going to do is we're going to do more of a single-page application. We're going to have the application running on your browser, and then we're just going to fetch the data. And the response time to the end user is much quicker. They like this. Not clear the screen, reload all your libraries and stuff, and reload all the page. It's like updates the screen. Because all it did is it made a request to the server, probably for RESTful data, pulled that RESTful data in, and rendered it in the page. And they did that without actually having to redraw the page, only the parts they changed. So it's good for that. So it's got built-in data binding and formatting, network communication, so it can make these calls. It has its own internal routing and navigation. The reason you might need that is you might have multiple pages that you can go between, but they're all happening on your browser. It supports modular architecture, MVC. They're moving a little bit away from that, but the traditional approach. Relatively easy to extend, to add things to it. And testing frameworks are it's friendly with certain testing frameworks as well. So let's take a look. So HTML was designed for static documents. So that's how we originally did that. And back in the early days when I started developing web pages, back in the 90s, static documents. In fact, lots of places they just have like one long HTML page that went on for days. You just scroll through it. Okay, so what happens today is we have more complex requirements. We want to display data. We want to collect data from users. We want to exchange data with the server. We want to navigate between views or look like pages without going back to the server. It offloads the server in that sense. So to do this, there's a lot of JavaScript code is needed, and I have done it the traditional way, just in JavaScript, and also using jQuery, which is another front-end library that we mentioned briefly before, to do this. Angular takes that one step further and makes it quite a bit easier to do the client-side stuff. Okay, so it simplifies, modularizes, and integrates navigation into it. Okay, so let's see. So the idea of Angular was to refine and extend functionality delivered in AngularJS. Okay, so I guess that's a naming thing is a bit funny. So that's AngularJS and Angular 1X. So both of them use this shift from server-side scripting or server-side including to client-side programming, and you're essentially working in JavaScript, but there's a whole lot of tools that you can use within Angular to build the pages. So the idea is that we reduce the concept of full page load into the browser. We pull in the initial application, and then we update it as necessary, and we might move from one screen to the other, but not actually leave that individual page. It's hiding and showing parts of the page and things like that. Okay, so we can actually provide navigation, so even URLs that work in the same page without going anywhere. It supports something that we call a single page application, or SPA. And the idea here is that we pull one page in, and then we might stay entirely on that page and only fetch bits of data to update the page. The response time is quicker, and it offloads the server from some of the traditional tasks that it would have to do. Also, modularizing of code for easier maintenance and testing. They have some the rules that you can follow, and Angular 4 is using somewhat similar to the Node.js require sort of type module handling, and you'll see that. So what have they done when they went from AngularJS to Angular, or from Angular to Angular, or from 1x to 2x? What did they do? Well, they kind of got some flack from the community about certain things. And they said, well, we don't want controllers anymore, so we're going to get rid of controllers, and we're going to use components. So now they're using really the component-based approach of web development, and it's very common in a lot of the other frameworks. So a lot of the frameworks are using that. So we build this chunk of web development, and we should be able to reuse that in other places. Okay? So the idea is it gives us more reusability. Whereas the traditional controllers used in Angular, they're kind of wired into what you were doing. So code is now separated into modules, and it can be loaded outside of the main HTML file. What that means is we bring in a sort of a shell skeleton HTML document, and then we can pull sections of not only data from the database, but sections of HTML in to show part of a screen that wasn't originally loaded. And now we have it, and we pull in the ones we need, and they come in pretty quick too, and they don't really do a clear screen reload type of thing, so they happen pretty fast. The functionality and the response time for the end user is fairly good, fairly significant. Also, variables and function names are private to modules. You say, well, yeah, that would be a good idea, except it's not the way JavaScript is. But it is in Angular. So they have taken some steps to do that, and it's a good idea, because in the traditional old style of JavaScript applications, and it was like way too many global variables, and so they have ways around that. Angular 2+, 4, 5 uses something called TypeScript for adding typing, so that if you want to, you can identify types, and then it will check to see that you've violated that type. So this is a character string. You try to assign a number to it later, then it'll say, oh, you can't do that, and it'll give you an error. And so it does look after type safety for you. Now that's done with something called TypeScript, and TypeScript is a preprocessor, and TypeScript runs under Node.js. So you end up sort of pre-compiling or pre-transpiling is what they call it, transpiling your TypeScript into actual JavaScript, because that's what runs on the browser. So that process takes place. And if you work in React, which is another competing framework, you end up using a language that they call JSX, and you also end up compiling the JSX or transpiling it into regular JavaScript as well. Again, using Node.js. So it's a similar kind of environment that are used for most of the frameworks. Services. The idea of a service was it was something that you could inject into a number of pages, and they could reuse it. For example, I might have a service that goes out to the server and fetches data about employees. And so I might have this employee service. Well, maybe I want to use that in several different pages. I could just, they say, inject it in and be able to use it from a number of places. Okay? So there's a number of features, and we'll see some of them here. Right. isn't it Angular 2? Well, I don't go too much deep into this page because I've already talked about that a little bit. It was a complete rewrite, and the syntax isn't changed entirely. So this has sort of caused a little bit of issue. It's not, if you have an Angular application now called AngularJS, it's very, very difficult to use Angular 2 with it. You rewrite it at this point. It's not upward compatible, and that's kind of caused some difficulty for some people, including myself, because I did a lot of Angular development. It's not really worth it. The other thing is they started to use semantic versioning, and the idea of semantic versioning is we have a major number, that's 4, so that's Angular 4. We have a minor number, and a minor version says there's new non-breaking features are added, and then we have a patch version, that's this one here, that's the patch, and that means it's just a non-breaking bug fix. So based on that, so if you go from 4 to 5, then there could be breaking changes. There was a couple of things added between 2 and 4, but no breaking changes in that at that time. Now when we go from 4 to 5, that could change. So there's to be a new major version of Angular about every 6 months. That's why we expect one any time. 4 is released in March 17, so we should see it almost any time now, Angular 5. So Angular 2 should only be used to refer to that specific version of Angular. So Angular 2 is Angular 2 dot blah blah, and then it's Angular 4 dot blah blah, which is current now, and soon to be Angular 5.00, I guess. So in order to install Angular and use it, it relies on a number of JavaScript libraries, and we can use the Node Package Manager that we saw before in the previous chapter to be able to install it. And what we use is we create a file called a package.json, and it's a JSON file, and it contains a list of all of the pieces that you would need for this particular package. So that's the thing that determines the requirements. So they have the COM and the compiler, core, forms, HTTP, platform browser dynamic, and the router. These are all parts of Angular, and it tends to put them into Angular directory. There are other necessary parts. So leave that there. Yeah, I hope the new major version isn't completely different than 4. The only thing that they've said is that they could introduce breaking changes between 4 and 5, but I haven't been following close enough to see if they actually have. Okay, yeah. Yep, that's it. I hope not. Well, depends on if you're working with 2. What happened is they were late coming out with 2. It was supposed to come out in January, and we saw it in the fall last year, about a year ago. And because it was late, and because rumor was that it was going to be completely different and you would throw away all your previous stuff, and people started looking around at things like Vue.js and Aurelia and React. And so I think the community's somewhat split now. It wasn't just, okay, we've got the new version, let's start working with it. It's like if you've got Angular stuff from Angular 1X, you're maintaining that separately. And they maintain that they're going to keep it alive for some period of time. They haven't said how long. And if you're doing Angular 2, you're probably starting a new project. So here's the other ones that are in there that you need. Some of the other libraries, Zone.js, Reflect metadata used for the decorators. System.js is used for the loader, and this is all part of the loader. But what it boils down to is this is your main web page. That's all that's on it. System.import app, and if there's an error, then we're going to print it on the console. But there's no more HTML in the main page. It's just this. And System.js is the loader, and it'll bring in the app, and the app will have associated pieces, and you build all that on your development system, and you build it all with Node.js and a few other things. So what do we have? Similar things we had before. We have modules where we can sort of group functionality together. We have components, and the idea of a component is a reusable piece that we can put maybe several times on a page or on multiple pages. We also have templates. Template is part of a component. So a component consists of some executable code in JavaScript or TypeScript, and a template which represents the HTML. So that's where your HTML goes, is in here. Metadata. They're kind of heavy on metadata, keeping track of things about the template and about options and that sort of stuff. They still support data binding, but they got a bit of flack from React, who does one-way data binding, and they say, but we're much faster. So now there's sort of reactive data binding and one-way data binding, and it used to be all two-way data binding in Angular, but that's changed. It's now just muddy water. Directives. Directives are still there. We don't use them as much. Now, what a directive is in Angular, you have like regular HTML, and then inside of that, you might have some other thing that's not HTML, maybe my directive, and you would write that yourself, and you would be able to use it. That's traditionally how that would work. That's called a directive. You still do that, but a component is essentially a directive. So you tend to be making a lot more components and less pure directives. You still do it, but not so much. And services, as I mentioned before, the idea of a service is some kind of usually non-graphical type functionality, maybe an employee object, or an employee service that does all of the interaction with the employee part of the database. Dependency injection, the idea is that we can insert something into another component and make use of it. So services are effectively injected into components. So here's a simple Angular application. Register for a newsletter, give us your email address, hit subscribe, and then it'll say type your email address, hit subscribe, you put your email address, you hit subscribe, and there it is. Okay, so this is made up of the following files. Index.html, which is the top end. That's the one that we saw in the previous slide there. App.module.ts, so that's where app comes from, and that's in TS means TypeScript, so it's written in TypeScript, so we're no longer writing in JavaScript. Mind you, they're close. It's JavaScript with typing, but it still needs to be transpiled before you can use it. Then there's a main and a register.ts. That's the registration component that they're using here. It's just a little bit more, dig in a little bit deeper. So here's the basic HTML file, and as you can see here, the libraries that we need, those are the additional libraries: Core.js, Zone.js, Reflect Metadata, System.js. These are parts that Angular uses, third-party libraries that Angular uses. There's more. I got a question here. Business logic. I would suggest that you might want to think about putting that on the server. However, if you put it in Angular, it would go in the component, because the component is the template, which is the HTML that you're going to render, and then the JavaScript part of that would be the logic associated with it. It's kind of like the controller, but they don't want to call it that because they'll get their knuckles wrapped for that. So that's where it would go. And it's distributed because each component has its own, and they're isolated, right? Okay, so we use Webpack and skip shim min.js. I don't know about shim. I don't see it in here. Shim, I've run across it before, but I'm fuzzy on it. I think it was used with Angular 1. But Webpack is just one of the tools that you can use to build the system, and it knows about these other things, like it'll run TypeScript and it'll create what we call bundles and work that way. Okay. It's in the PDF. Where's the shim? Is that in the next page? Don't see it here. Is your slide different than mine, perhaps? I don't know. Do I have the PDF here? Oh. Are you getting the same slide? Same slide. Okay. I don't see it. Should be on my screen, right? Mm-hmm. Don't see it. Shim. Oh, here. Right. Yeah, these are just all pieces of like third-party libraries and things that are. I think the shim is the. Yeah, I see what you're getting at. in this example, you can do TypeScript a couple of different ways. One is you can get it to work in the browser, and you can do Babel in that way as well. And that may be what that is. It seems to me that's what that is. Okay, I got it now. I think that's what that is. Correct. If you build this stuff on your server with something like Webpack or Babel or something like that, you probably wouldn't use that. That's correct. That's absolutely correct. Yeah. And that's because you don't really want to do it on the fly, but you might do it that way in development, which is why it appears here. Okay? Yeah, that's what that is. That's why I don't see it, because I build it on the server side all the time. Okay, so there's the other part that we saw before, the system import, app, and so this is the actual application here. It's a directive, or in fact a component. They're kind of the same. And so we have a subscribe, and the subscribe component then would have a template, and then the template would have associated with it the various logic, which essentially would be the business logic for the subscribe. And I think we're going to see more of how this works. Okay, so application module. Again, they're using import here, but it's the same kind of syntax, and we tell it where to pick that up from. This is our register component that we're going to load in, and we're going to tell it that it's just down underneath the current directory. So we're defining a module. We're declaring things that we need to use, so subscribe newsletter, and what we're going to start up with, subscribe newsletter, and we're going to need the browser module for that. So 1 and 2 Angular will always have these. These are ng module and browser module. So this is just sort of the very core parts of Angular. 3 imports the custom component. Here's 3 here. So that's the register component. The @ng module decorator begins the application module definition. Okay. And we declare any modules needed by the application here. And line 6 is the list of application components declared by the module. It's very configuration heavy. Angular has been that way for some time. The main application view is the root component. This is 7, so this is the one we're going to bootstrap. So that'll be the startup one. And then the class decorator is attached to and will be referenced elsewhere. Okay. So here's the bootstrap. Again, this is sort of almost boilerplate parts of Angular. You're all going to need something pretty much exactly like this. And so we're going to use app module, and we're importing the app module from the previous page. And we're going to need platform browser dynamic and platform bootstrap. And we're going to boot the app module. So again, this is, you can change it, but it's sort of fairly standard, so you don't really need to change it very much. So again, import the browser module, import the application module, and load the application. Okay, so that's what the bootstrap file is doing. So now we get down to the meat. This is the actual component down here. So this is where you would write the part that you would normally write. You just use the other stuff almost as it is. If you get in fairly deep, you might find there are things you want to tweak in there, but for the most part, just keep it the way it is. Okay, so import component from Angular core. So it needs to know what a component is. So we're going to declare a component, and it has a selector. Rather than flip back 2 or 3 pages, I'll try to describe what the selector is. Remember the thing we had was subscribe? /subscribe, that's called a selector. So you tell it here what that selector is going to be, and when it encounters this, it looks for a component that has that selector. Okay, so that's how that connection is made there. Then you have the template, and the template is the HTML, and it starts here, and it ends here. Now this is using an ES6 feature called multi-line strings. Okay, that's what the backquote is. So it's a string, but it can cross multiple lines. Which, if you've done this stuff in the past where you want to have a long string, it's like this, plus this, plus that. No, it's messy. So this is the ES6 features. TypeScript fully supports the ES6 syntax, and so therefore you can use ES6 features in your TypeScript, and it will convert them as necessary when it does the TypeScript compiling. So what do we got? This looks like regular HTML pretty well till we get to here. Okay, and then we have this. And that's pretty well it. And then there's that. Okay, so those are bits of Angular. They're actually Angular directives. So ng model says this is bidirectional on email. This is single direction on register email. When you click the button, we're going to call this function. And this is a one-way data bind from Angular coming out onto the screen. So a little bit more on those a bit later. You can specify in your components specific styles. Again, multi-line string. The nice thing about that is you can isolate a style to a component. And one of the problems with cascading style sheets is that they cascade. And sometimes they get you into trouble later in the game. So it allows you to put your style right into your component. Okay, so that this is just regular CSS in here. Okay, and I think we're going to do these in a little bit more detail here. So we'll leave that. So export, this is the other part. This is down underneath. So let's see the three dots here. This is the description and the template. And this is the TypeScript down here. Okay, so it's kind of like JavaScript, except we're going to create a class, export class subscribe newsletter. That's a class between here and here. And then we have message, which is of type string. That is TypeScript. You're telling TypeScript that message is a string, and we're assigning. So other than that, it's a JavaScript string. But if you try to assign a number to it, TypeScript's going to pick up on that. And we have an email, which is also a string, and it's uninitialized. And we noticed we had the click button. We're going to call a function called register email. Well, here it is. And then we can refer to this, which is our instance of this class. This .message is equal to this.email plus is now subscribed. So what will happen is we assign that to message. And since message is, I'm going to see if I can clear up some of this stuff here. No, I can't. Okay. What's going to happen is that that's going to get rendered right in here inside of the paragraph headings. Okay. So when we assign it in the JavaScript, it renders here. Okay. Well, so we got one-way and two-way data binding going on here. We set up the message, and that's its initial value, and then we modify the message here, and that its new value will automatically get reflected on the screen. Major changes in 4, not many. As I said before, not many major changes. They added a few things, but they really didn't break anything this time, which is good because people are kind of a little bit annoyed about 2. So, not very much. So Angular animations feature taken out of the core module and put in a separate animations module. Doesn't really impact very much. You might have to move a library or something. The applications not using animations are not included in resource for them. Okay. Some enhancements in the options for ngIf and ng4 directives. If you weren't using those enhancements, then you would have no problem. They were just added in. You could use them if you want, so it's not a breaking change, really. Okay, a lot of stuff behind the scenes. Changes to generating code. They went from TypeScript 2.1 to 2.2. Source maps for templates for debugging, and packaging changes, flat ES modules, and things like that. So they changed some stuff inside and made it a little bit better, but they didn't change very much outside. And we expect 5 very shortly. Let's see if I can get a... Just go to Angular.io and it'll probably say... No, not saying anything yet here. They're having an event in October. October's gone. No, they're not saying anything specific, but we expect it any time. We expect to see that come out any time. Okay, just an introduction to doing things in Angular, and that's a very simple application. You can see there's quite a lot to it, but the meat and potatoes is the component. And I'm just going to skip back to the component again here. I can't get the marks to go away, so that's okay. Main thing is we have to tell it we're using a component. We have a selector which tells it what it's going to look like when it appears. You can put components inside other components, right? So that you put it in a template. We have the template, which is the HTML, and it has some embedded Angular. These are actually directives, right? And so those are Angular bits that are embedded in the template. We can optionally have styles. On the next section, we see we're going to create a class. That class will have all of the logic that's being used inside of our application, and it's sort of isolated. There could be multiple instances of that component on the page. They would not interfere with each other because it would be another instance of the same component class. Okay, so that's just a little review of that section. So in this chapter, a high-level overview of Angular and what it is and why it's used, how to install Angular and its related JavaScript libraries, reviewed the components of a basic Angular application, and once again, you can use with mean, you can substitute most of the parts. You're going to probably have Node.js no matter what you're doing, whether you're using it in the server or using it to build things on the client side. But you could, for example, use React for the front end or Vue.js, whatever worked. You would still use Node.js. You possibly still use Express, possibly still use Mongo, or you might use another database in a different way. So these are just some of the tools that you have available in working with some of this type of environment. So do we have any questions? There's a question. Node.js and Angular are integrated. Well, basically, Angular ends up being static, pretty much static pages almost at the end after it's compiled. So Node.js is used, for example, usually through TypeScript to transpile the source code of the Angular stuff and turn it into something that can be delivered to the browser. And that gets served up by Express. And you can use Express or you can use any other web server to serve it up, and it gets pulled in. And so basically it fetches the pieces it wants. So it's like a conventional web page, but it'll bring chunks of HTML, which are compiled components, and pull them in and put them into your page. Can we add Bootstrap in the component section? Well, Bootstrap is just basically CSS, so you could put it in the style section if you want, and you could use it from there, or you could use it anywhere else you want. You can use it directly inside of the template. It doesn't interfere either way with Angular. There's no interaction. It's just something else that it ignores, but Bootstrap renders it properly. Yes, I believe TypeScript is a Microsoft tool. Yeah, I believe it is. Okay. Anything else? Okay, so it's going to be here for a little bit if you have another question, but that's what I have for you this afternoon. Thank you very much for